Have you ever wondered how a steam engine, a technology from the 18th century, can power a massive locomotive? Well, you're not alone. The steam engine, a marvel of the Industrial Revolution, is a fascinating study of innovation and engineering. Now let's take a moment to appreciate the steam engine's historical significance. Born out of the 18th century, this powerful invention played a pivotal role in transforming the world we know. It revolutionized transportation, making it possible to move goods and people faster and further than ever before. The steam engine was a game changer, ushering in the era of industrialization and modernity. But what is a steam engine, you ask? At its core, a steam engine is a heat engine that performs mechanical work using steam as its working fluid. It's a beautiful blend of science and engineering, a testament to human ingenuity. The steam engine is made up of several key components: the boiler, the cylinder, the piston, and the condenser, to name a few. The boiler, as the name suggests, is where water is heated to produce steam. The cylinder and piston are where the magic happens, where steam's power is harnessed and transformed into motion. And the condenser, well, that's where the steam is cooled and converted back into water, ready to be heated again in the boiler. It's a cyclical process, a dance of heat, pressure, and motion. But don't be fooled by the simplicity of its components. The steam engine is a complex machine, each part working in harmony with the others to achieve a common goal: to convert heat energy into mechanical energy, and in turn power a locomotive, a ship, or even a factory. So how does this seemingly simple machine manage to perform such a colossal task? Let's delve into the mechanics of a steam engine. It's time to unlock the mystery of this extraordinary machine, to understand how it has shaped our world and continues to inspire us even today. At the heart of every steam engine lies the boiler, a high-pressure steam generator. Imagine a kettle, but on a much larger scale, and instead of using it to brew a nice cup of tea, we're using it to power a machine. That's essentially what a boiler is. It's a large container, often made of steel or iron, filled with water. A heat source, frequently coal or wood, is used to heat the water in the boiler. As the water heats up, it begins to boil, and steam is produced. But this isn't your average steam. This steam is under high pressure. Think of it as a steamy superpower, ready to be harnessed. Now you might be wondering, why do we need the steam to be under high pressure? Well, the answer is simple: power. High-pressure steam contains a lot of energy. The higher the pressure, the more energy the steam has. And it's this energy that we're interested in. You see, a steam engine is all about converting one form of energy into another. In this case, we're turning the thermal energy from the heat source into mechanical energy. And to do that, we need as much energy as we can get. The steam generated in the boiler is stored until it's needed. When it's time to put that steam to work, it's released. But we don't just let it out all willy-nilly. No, we control the release of the steam to ensure we're getting the most out of it. This is done through a series of valves and pipes, which we'll explore in more detail later. So, in a nutshell, the boiler's role in a steam engine is to generate high-pressure steam. It's the first step in the process, setting the stage for the rest of the engine's operations. Now that we have the steam, how do we convert this into motion? This is where the piston comes into play. The piston, a simple yet ingenious device, is responsible for converting the high-pressure steam into motion. Let's take a closer look at this marvel of engineering. The piston, a cylindrical component, is situated inside the cylinder of the steam engine. It's essentially the heart of the engine, driving the whole process forward. Here's how it works. When high-pressure steam is introduced into the cylinder, it fills the space and pushes against the piston. Just like when you blow up a balloon and let it go, the force of the air propelling out of the balloon sends it flying across the room. In the case of the steam engine, the force of the steam propels the piston forward in the cylinder. Now, this piston isn't just floating around aimlessly. It's connected to a wheel or a series of wheels via a rod, often referred to as the piston rod. As the piston moves forward in the cylinder, the piston rod follows, and the wheels begin to turn. At this point, you might be thinking, well, that's all well and good. But what happens when the piston reaches the end of the cylinder? That's a great question. The answer lies in the steam engine's ingenious design. Remember how we said the high-pressure steam pushes the piston forward? Well, once the piston reaches the end of the cylinder, a valve lets out the spent steam and introduces fresh high-pressure steam to the other side of the piston. This new influx of steam pushes the piston back the other way, and the wheels continue to turn. So, in essence, the piston is like a swing. constantly being pushed back and forth by the steam. This back and forth, or reciprocating motion, is what keeps the wheels of the steam engine turning, converting the power of steam into motion. So we have motion, but how does the engine manage to keep this motion going? This is the role of the condenser. The condenser is what keeps the steam engine running smoothly, ensuring the continuous movement of the piston. Imagine a steam engine as a never-ending cycle, a dance of sorts, where each component plays a critical role. The condenser is an unsung hero in this dance. So, what is the role of the condenser in a steam engine? Well, it's all about cooling and recycling. After the steam has done its job in the cylinder by moving the piston, it doesn't just disappear. It needs to be dealt with, and that's where the condenser steps in. The condenser is a device used to cool down the steam that has passed through the piston. It's essentially a large metal chamber, often filled with cold water, where the steam is directed. A steam engine is a symphony of different components working together to create motion. Their function is a beautiful dance of physics and engineering. The performance begins with the boiler, a hot-blooded performer that heats water to produce steam. This steam, under high pressure, is then directed towards the piston. The piston, our diligent dancer, moves back and forth under the force of the steam, converting the steam's energy into mechanical motion. But the show doesn't end there. The steam, having done its job, is not left to linger. It is ushered into the condenser, the backstage of our symphony. Here, it is cooled and converted back into water, ready to start the performance anew. This continuous cycle of heating, moving, and cooling is the rhythm to which the steam engine dances. The steam engine then is a harmonious ensemble of boiler, piston, and condenser. And that's how a steam engine works, a testament to the ingenuity of human engineering.